Hey, how's it going on, guys? So in this video we'll discuss about this problem: insert, delete, get random O1. So in this question we have to design a data structure which supports the following operations, that is insert value, remove value and get random in O1 time complexity. So insert value inserts an item value to the set if not already present. Remove value removes an item value from the set if present, and get random returns a random element from the current set of elements, and each element must have the same probability of being returned. So let us see how we can solve this problem. Now the first thing that comes to our mind is hash map. Why hash map? Because we all know that hash map provides O1 inserts and O1 remove. The problem is with this method get random. This can't be O1. Reason being, the idea behind get random is going to be to choose a random index and then retrieve the element with that index. The problem with hash map is there is no index in hash map. So you won't be able to achieve this method in O1 time complexity. So let us move to approach 2, which is a simple list. Now simple list provides you an O1 insert and O1 get random. Why O1 get random? See, when you have a list, you can find the size of the list in O1 time complexity using list.size. Once you have the size, you have the possible index, that is from 0 to list.size -1. Now from this possible range, you can select any random number and you can simply return the value at that random index. So that's why this method is going to be O1. The problem is with this remove method, which is going to be O1. So again, this approach is not going to work. So let us move to approach number 3, which is list plus hash map. See, we already know that we can achieve O1 time complexity for insert and get random using only list. Now we are going to add hash map into it. So let us see how. So let us suppose our list is something like this. That is, we have these inserts. We have insert 20, insert 2, insert 12, insert 18 and insert 7. And these are the indices 0, 1, 2, 3, 4. So in map, what we are going to have is for 20, it is linked to 0. So you can have 20 is pointing to 0. So this is the key and this is the value. Similarly, for here we will have 2, 1. So we will have 2 as a key and 1 as a value. So we simply have a linkage from the value to its corresponding index. Now let us see how we can achieve this remove value in O1 time complexity. Okay, one important concept over here is that, see, if you are removing an element from the list, from the middle of the list, it's O1 time complexity. Reason being, suppose I am removing this element. If I remove this element, then this creates a hole. So in that case, I have to shift all the elements on the right of it one step on the left. That's why the complexity is O(n). But in case I'm removing the last element, in that case the time complexity is 1. So this is a very important concept. What I'm saying is, for list, the remove method works in O(n) time, but in case you're removing the last element, it works in O(1) time. Alright. Now what can I do is, I can use this property and this map data structure to achieve O(n) time complexity for remove. So let us see how. So let us consider we have to remove this value 2. So suppose we have this thing, remove 2. So what we're going to do is, first we will go to the map and we will check for its index. So you will get its index as 1 in O1 time complexity. So now I know that in the list 2 is present at index 1. Now what can I do is, what I will do is, I'll take this value and I'll take the last value. So we can access this value as well in O1 time complexity. Now what I will do is, I'll copy this value over here. So I'll copy the last value over here. So this becomes 7. Correct. So once this becomes 7, what I will do is, I'll update this 7,1 in the map. So initially 7 is pointing to 4 because that was its original index, but now I have changed it. So over here I'll go and I'll change it to 1. After this, I'll simply remove the last entry from the list. So I'll remove this entire entry. So let me just remove this. So after removing this also is O1 time complexity operation. And then what we will do is, since we have removed 2, so we have to remove this entry from the map as well. So we can remove this entry from the map using O1 time complexity. So we have like 3 to 4 steps, but all these steps works in O1 time complexity. So I've written the algorithm over here as well. So if you want to read the algorithm, you can pause the video and you can read the algorithm. It's a pretty straightforward algorithm. So now what will I do is I'll just write the code for this question, and then things will be more clear. So initially we'll be having a list of integer, let us name it list. Then we have a map of integer comma integer, let us name it map, and we will have a random variable as well. So we will have random. In the constructor, I'll initialize list as new array list. I'll initialize map as new hash map of integer comma integer, and random equals new random. Okay, so let us write the insert and get random method first, because they're going to be straightforward. So in insert, we will first check whether this value is present in the map or not. If this value is not present in the map, we can simply return a false from here. Otherwise, what will I do is I'll first add the current element in the list, and we will add the entry in the map as well, that is value with list dot size -1, and after this we will simply return true. Okay, why I'm adding value comma list dot size -1? Reason being, we are adding the element at the last of the list, correct? So this will point to the last index, which is the correct position for value. So I guess insert is done. What about random? So in random, what you can do is you can simply return list dot get, and from random you will say random dot next int, and here you can simply provide list dot size. So what this will do is it will create random numbers from 0 to list dot size -1, and then you can return that element. So this is also O1 time complexity. Now comes a remove method. So first we will check whether this value lies in the map or not. In case it is not lying in the map, we will simply return a false. Now what we will do? So there were like 4 to 5 steps. The first step is to find the index for this value. So we can find that index using what? Using map. So we will say map dot get of value. Once we have this index, we know this value is present at this index in the list. Now what we will do is we will find the last element, which is nothing but map dot get of, not map dot get, this is list dot get, and here we will provide list dot size -1, correct? And what you will do is you will simply say list dot set. At this index you will set this element, correct? That's what we are doing. So I'll set over here. So after setting, I know the position is changed for this element, so I'll update in the map as well. So I'll say map dot put for this last element, the new index is idx. Now what we have to do is we have to remove the entry, the old entry from the map as well as from the list. So simply from the list we will say list dot remove list dot size -1. We are removing the last entry from the list, which is O1 time complexity, and we will remove this value from the map as well. And after this is done, we will simply return a true. So I guess that's it. Let me run this code once. So it's giving a runtime error. Okay, so I was making a mistake over here. So what I was doing is, if it is not in the map, then I was returning false. Actually, if it is there in the map, then we should return false. Otherwise we have to insert. So let me submit the code once. and it got accepted. So I guess that's it from this video. In case you have learned anything from the video, you can hit that like button, and in order to support my work, you may consider subscribing to my channel. Thank you all.